Hey guys, welcome to week 2 of distance learning. Last week in pre-calculus, we talked about polar coordinates and polar functions and how they look on a graph. So last week's assignment is going to be due by the end of the day, Monday. So I wanted to go ahead and give you the next installment for those of you who want to go ahead and get a jump on this next piece. This is going to be the last 2 assignments for this chapter. So this assignment is going to be changing polars to rectangulars and vice versa. So being able to go from a polar or circular graph to more of your XY regular graph. So for this week you'll be having 2 assignments. One is going to be in the textbook and then the other one's going to be a summation of the chapter on polar coordinates, polar graphing, and of course changing rectangular to polar. So with that being said, let's go ahead and jump into how to change from rectangular to polar and vice versa. When it comes to this week's information, you're going to need a few formulas. Okay, these are going to be your templates to solve the questions in this section. I'm going to go ahead and put up all 4 of the formulas up here on this whiteboard so that you'll have them for the rest of these questions that we work through. Okay, so these are your 4 formulas that you're going to be using for this section. You have an x and y equals formula, so you're able to plug in what r and theta are, which are your polar coordinates, okay, and you're able to plug them in and get x and y, and then vice versa. If you have x and y, you can reverse it and use these 2 formulas to get r and theta. So, first formula, x equals r cosine of theta. Second formula, y equals r sine of theta. Third formula is r equals the square root of x squared plus y squared. And then the fourth formula, theta equals the tan negative 1 of y over x. Now that we have these formulas down, we're going to look at about 4 to 5 problems that take us through how to convert just the ordered pair points and then show us how to convert in function form. So for this first example, you have 5 and then radians over 3. So if you're following along, this is example 1b from the textbook in this section, section 9.3. And so since this is giving us an r and a theta, we know that we are going to convert from polar to rectangular. So for this particular question, all you have to do is take the r and the theta and plug it into the x equation and then plug it into the y equation. So once you write that down, all you do is calculate that. You can put it into a fraction or you can put it into a decimal. I'm going to go ahead and put them both into their fraction form. So for the top one and the bottom one, the x value is going to be 5 over 2 or 2.5. And then the y value is going to be 5 square root of 3 over 2. Reason why it's square root of 3 over 2 is if you look at the sign of radian over 3 on a unit circle, you'll see why we're using the square root of 3. And that's your answer. Now let's look at example 2. Example 2 is going to be going the reverse. I'm going to give you the rectangular coordinates and we're going to get the polar coordinates. So for this example, example 2, we're going to be using example 2a from the section 9.3, and so what we have is 810. 810 is our ordered pair, x and y. So since we know we're given x and y, we're going to go from rectangular to polar. There again, with coordinates, it's pretty quick, pretty simple, plug and chug. X into the x spot, y into the y spot, and you have an answer. Okay, so for the r, square root of 8 squared plus 10 squared. And then for your theta, tan negative 1 of y over x. So 10 over 8 So calculate, get an answer. And there you go. Those are your two answers, first two examples. This is how you work the coordinates from polar to rectangular and rectangular to polar. Now the last two examples are going to be for the functions. Okay, so for this first example, we're going to be going from a rectangular equation to a polar equation. You'll notice from last week's assignment that the polar equation that you want to get is r equals. You noticed that a lot last week when you were going through and graphing some of these equations. R equals is what you want. It's kind of like y equals for functions. So for this particular equation, you have x and y. Your first step is to replace your x and your y. Replace your x and your y first. You're going to replace those with r cosine of theta and r sine of theta. So now that we replaced them, what we're going to do is we're going to simplify. It's a little tedious in here as we go through because you're going to distribute your squared to the first piece. Okay, so you're going to have r squared cosine squared. And then the second piece, you're going to have to go through and FOIL this. So watch how I do it and make sure you're following along, and feel free, post questions below. Square distributes to both pieces there, and then over here, write it twice and FOIL. So now what you're going to do is you're going to combine the like terms here, the negative 3r sines, together to make negative 6r sine. And then the next thing while we're doing that is to subtract over the 9. So that we have this whole equation equals 0. So now that we've gotten to this point, what we're going to do now is we're going to go ahead and do the same thing that you see in the first example in example 4 in the textbook. We're going to end up taking out the r squared. We're going to factor out the r squared from our first two pieces here, because when we do, we're left with sine squared plus cosine squared. That's important because that's one of the Pythagorean identities that we learned about a month and a half ago. Actually, probably more than that. But we're going to take sine squared plus cosine squared because that equals 1. So watch these next two lines and you'll see exactly what I'm talking about. We're going to go ahead and factor out the r squared. So we factored it out right here, and this equals 1, because sine squared and cosine squared equals 1. So that's where we are. So r squared times 1 minus 6r sine of theta equals 0. From here, we're going to go ahead and solve for r. How we do that is, for this particular case, we're going to go ahead and move the 6r sine over and then divide an r from both pieces. So adding the 6r sine over, and then we can cancel out an r from both sides, leaving us r equals 6 sine of theta. Now let's look at example number 2 for the functions. Okay, for the last example 2, and then I threw in an extra example 3, just because, why not, do more math. But example 2, you have theta. Theta is equal to radian over 3. That is a function in polar form that we're going to change to rectangular form. Okay, so this is going to rely on this tan negative 1 formula. Okay, so if you look at this tan negative 1 formula, okay, if you plugged it in, we want to get y equals. That's a rectangular function, y equals. So that's what we need to do. We need to solve for that little y there. So we're going to work backwards. So watch what happens here. When you see the tan negative 1 and you need to move it over, you simply take the tan to the other side. So when you move the tan over, looks a little smudged, but when you move the tan over, it goes from tan negative 1 to tangent on the other side. So if you look at the formula, you could rewrite the formula as tan of theta equals y over x. That's also good to do. So using the unit circle, or plugging it in, tan radian over 3 is simply the square root of 3. Okay, so square root of 3 equals y over x, so all you have to do is solve for y. So this rectangular form is y equals the square root of 3x. And then for the last one, r equals, I think this one's even easier because all you're going to do is sub it into the r equals square root of x squared plus y squared. And with this one, watch this. That's it. X squared plus y squared equals 9. So when you think about this formula up here at the top, okay, r equals the square root of x squared plus y squared. But when we solve for these functions, the first step is to move that square root. So if you want to think about this one, another way to think about it is r squared equals x squared plus y squared. And in that case, you kind of get the gist of what this is going to be. Okay, so you can think back to geometry, algebra 2, x squared plus y squared equals 9, a circle. So if r equals negative 3, just like last week, it was a radius of negative 3 all the way around the circle, so it was still a circle. That's it. All right, guys, now that we've finished the examples, what you're going to see is you're going to see the assignment below. Okay, so go ahead. Start on the assignment below. Make sure to watch the numbers that you're supposed to do. Okay, make sure you're asking questions. I'll be there to answer your questions whenever you post them. Okay, feel free, email me if you need to. And then the second assignment for the week. Once I give you a chance to finish writing that down. The second assignment for this week, okay, this is going to be due next Tuesday. This is going to be due next Tuesday. It's a little bit of a longer stretch to be able to turn this in because it's going to be a 2-page paper. And it's going to summarize polar graphs, polar functions. I want you to write a 2-page paper on the importance of polar graphs, because a lot of people are asking that question, like, why are we working on polar graphs? Where are we going to use polar graphs? So due next Tuesday, I want you to write a 2-page paper on why polar graphs are important. And so that will summarize this entire chapter. So starting next week and around Tuesday to Wednesday, you're going to see another video to show you what's going to be due after that, moving into the next unit. The next few units are going to be talking about statistics information and talking about sequence information. So keep that in mind. This is kind of like one of the last real solid chunks of pre-calculus that can be a little bit confusing. So the next 3 units that we're looking at, sequences, studies, and then getting into intro to calculus if we get that far. With that being said, have a wonderful week and let me know if you need anything.